Good morning, children. We are starting the new chapter Haloalkenes and Haloarenes. This is the first chapter of your organic portion of class 12. Now, alkyl halides, or which are called as haloalkanes, are those hydrocarbons in which one of the hydrogen is being replaced by that of a halogen. And aryl halides or haloarenes are those hydrocarbons, or I should say in which one of the hydrogen of the arene ring or the benzene ring is replaced by halogen, are formed by the replacement of hydrogen atom in an aliphatic or aromatic hydrocarbon by halogen atom respectively. Okay, that is whenever we have a hydrogen atom of a alkane or hydrogen atom of a benzene ring is being replaced by a halogen, that becomes alkyl halides or haloalkenes, or aryl halides, which are called as haloarenes. So haloalkenes and haloarenes may be classified as follows. What are the first classification? First is monohaloalkane. In monohaloalkane, what we could see, that we have a single halogen which is getting replaced by the hydrogen present in an alkane. Then we have a dihaloalkane. In dihaloalkane, two of the halogens are getting replaced. In dihaloalkane, two of the hydrogen getting replaced, as in this case we could see we have ethane, two of the hydrogen replaced by halogen. Or it can be trihaloalkane. As you could see in a trihaloalkane, what is happening? Three of the hydrogen replaced by that of an halogen. Okay. In case of arene system also we have the same type of classification. In arene system we have monohaloarene, we have a dihaloarene, we have a trihaloarene. Okay. In this way we have this type of nomenclature. Now, monohalo compounds are further classified according to the hybridization of the carbon atom to which the carbon is bonded. Now the first is compounds containing sp3 hybridized carbon atom. Compounds containing sp3 hybridized carbon atom. Now in this case what we could just see, that here we have the C which is bonded with X, where X may be a chlorine, bromine or iodine. Now alkyl halides or haloalkanes are having the general formula Rx. In alkyl halide, the halogen atom is bonded to an alkyl group R, on the basis of the nature of carbon to which the halogen is attached. These are further classified as primary, secondary or tertiary. Okay. Then we have allylic halides. In allylic halide, the halogen atom is bonded to allylic carbon, which is sp3 hybridized carbon atom next to the carbon-carbon double bond. That is, it has this type of classification. Right, here we have the allylic carbon. So you could see if it has CH2 double bond CH, single bond CH, 3X, this is called as allylic carbon. After that we have the benzylic halides. In benzylic halides, what we could just see, that halogen atom is bonded to the benzylic carbon, which is sp3 hybridized carbon atom next to an aromatic ring. So it is bonded to that of aromatic ring. We have benzene ring with the CH2X. In this way the benzylic carbon has been attached to it. Okay. This may be also further classified as primary, secondary and tertiary. So we have the primary one, the secondary one and the tertiary one. But in case of aryl halides, here we have the tertiary one. Okay. So as you could just see in the primary carbon, what we have, a primary carbon, in a primary carbon, what we could just see, that here it has the carbon been attached with this. If it has CH2, then this is called primary carbon. If it has CH to here also primary carbon, in this case CH2X, in this case also, that is also a primary carbon. Yes, after that students, we have the secondary. So here you could see in this case of secondary we have a CH, that is secondary carbon atom. In this case also we have CH, secondary carbon. In the aryl system also we have CH, that is a secondary carbon. In case of tertiary we have no hydrogen present, so that is tertiary carbon atom. Here we have another one, that is also tertiary carbon atom. In this case also tertiary, we could see that there is not the presence of any hydrogen, so that becomes a tertiary carbon. After that, compounds containing sp2cx bond. If it contains sp2cx bond, then in this case we have this type of a structure. So in this case, what we see in vinylic halide, what we see, vinylic halide, the halogen atom is bonded to the vinylic carbon with sp2 hybridized carbon atom to a carbon-carbon double bond. In this case, in aryl halide, halogen atom is bonded to the sp2 hybridized carbon atom of an aromatic ring. So here you could see this structure directly attached to the X with a double bond. That is called vinylic halide. In arylic one, we have the CH3 over here in the benzene ring with the halogen attached to it. So dihalogen derivatives of alkenes, that is dihaloalkanes, may be further classified as geminal dihalide and vicinal dihalide. What is a geminal dihalide? If the halogen atom are in two adjacent carbon, if in geminal dihalides both the halogen atom are present on the same carbon atom, in case of geminal one they are present in the same carbon atom, in a vicinal one they are present in the adjacent one or just which is next to it. In vicinal dihalides, two halogen atoms are present on the adjacent carbon. If they are present in the adjacent carbon, then that becomes vicinal dihalide. If the halogen is present in the same carbon, then that becomes the geminal dihalide. This is the way by which we actually encounter these two different types of dihalides. Now, nomenclature, there are two types of names used for organic compounds. What are those? Common name. These name is derived by making alkyl aryl group followed by a halide. And then we have the IUPAC name. In the IUPAC name, the name is written by prefixing halo to the name of the parent hydrocarbon. We use the word halo before that of the parent hydrocarbon. So in this case, we have CH3CH2Br. We name this compound common name as N-propyl bromide, but the IUPAC name comes over here is 1-bromopropane. 1-bromopropane, because bromine is attached to the first carbon. See how many carbon are there? There are 3 carbon. So the parent compound is actually propane. Right now in the first position we have bromine attached, so the name becomes 1-bromopropane. See the next compound, again that is a propane, but in this case the chlorine is attached to the second position, so it is called as 2-chloropropane, or its common name is isopropyl chloride. So ultimately in this type of nomenclature, what we do, we name the compound based on adding a halo after the name of the parent hydrocarbon. After the name of the parent hydrocarbon, we put a word halo. In this way, we just name these compounds. After that, children, we have some other sets of compounds whose nomenclature is been written. We have the IUPAC name as well as the common name. The first compound we have over here, CH3CH, CH3CH2Cl. So if I remove the Cl, what is the name of the compound? The name of the compound is 2-methylpropane. And in the first position we have a Cl, so the name of the compound become 1-chloro-2-methylpropane, and the common name is isobutyl chloride. Why isobutyl? Because total number of carbon is 4, and as it is isobutyl group, so it is called isobutyl chloride. After that we have a benzene ring attached with the chlorine, so name of the compound become chlorobenzene, but common name is benzene chloride. Common name is benzene chloride, but the IUPAC name is chlorobenzene. After that we have H3CCHCl2. We have ethylene dichloride, that is 1,1-dichloroethane. We have 1,1-dichloroethane. Now the next one we have is ethylene dichloride. Ethylene dichloride, we have 2 of the chlorine attached and with ethylene ring attached to it, so we have ethylene dichloride, that is 1,2-dichloroethane. 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 Now in case of disubstituted haloarenes, that is the prefix ortho, meta, para are used for writing common names, but ortho, meta, para is not according to IUPAC nomenclature. In IUPAC nomenclature, we have to number it as 1, 2, 1, 3 or 1, 4 according to the location of those groups present. Okay. After that, see, we have this compound. In this we have a benzene ring with which we have methyl group as well as a Cl. So what is the name? common name is orthochlorotoluene. Why? Because both the positions are adjacent to each other, and as chlorine is attached to the ortho position, it is orthochlorotoluene. But what is the IUPAC name? 1-chloro-2-methylbenzene. 1-chloro-2-methylbenzene, or it is simply called 2-chlorotoluene, because just try to understand, a benzene ring with a CH3 is called toluene. Now to the second position, one chlorine is attached, so it is called 2-chloro. So it is called as 2-chlorotoluene. After that we have the next one, just see, again we have a toluene with a chlorine, so it is called as metachlorotoluene because their location is in the meta position, but IUPAC name is 3-chlorotoluene. Then we have bromine at two positions, so it is called meta-dibromobenzene. Why dibromo? Because two bromine atoms are present. After that we have 1,3-dibromobenzene, which is the IUPAC name. Why? Because benzene is the parent compound in position number 1, and position number 3 we have two of the bromine, so it is called 1,3-dibromobenzene. After that we have metachlorobromobenzene. Metachlorobromobenzene, why? Because bromine and chlorine are in the meta positions, so it is called 1-bromo-3-chlorobenzene. So it is called 1-bromo-3-chlorobenzene. Now just see the next one. Here we have a benzene ring with which alternating chlorine is attached. So the IUPAC name is 1,3,5-tribromobenzene, and the common name is symmetrical tribromo. Why it is symmetrical? Because location of bromine is in every alternate position. Bromine is not present in the same position. Bromine is present in 3 different positions in a symmetrical manner. So it is called as 1,3,5-tribromobenzene, or symmetrical tribromobenzene. This is how the nomenclature of the compounds of the haloalkanes are being named. Now here you just see, here we have further more nomenclature of various other compounds. The first one is that 2-chloro-3-methylpentane. So in this compound you can see that when they tell it 2-chloro-3-methylpentane, that means the parent compound is pentane. Pentane means how many carbon? 5 carbon are there. So we start the numbering from here, 1, 2, 3, 4, 5. So 5 carbon are there, that is pentane. Now they are telling in the 2 position we have a chloro, and the 3 position we have methyl. So name of the compound is 2-chloro-3-methylpentane. After that we have next compound 1-chloro-4-ethylcyclohexane. 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 This is the way we name the compound. After that we have the next compound, that is 4-tertiary butyl 3-iodoheftane. Iodoheftane is the parent compound. Heftane means what? Heftane means it has actually 7 carbon. So 1, 2, 3, 4, 5, 6, 7. So we just start the numbering from this position. This is the first position, second position, third position, fourth, fifth, sixth and 7. Now here they have mentioned that in the third position we have a iodo group. So here we mark iodine over here. Now see in the fourth position they have told you that we have a tertiary butyl group. What is tertiary butyl group? Tertiary butyl is actually 2-methylpropane. Tertiary butyl is 2-methylpropane. In this case we have 2-methylpropane attached over. In this case we are getting tertiary butyl chloride. Okay, this is how we are naming it. After that we have the next compound 1,4-dibromobutene. 1,4-dibromobutene. In this 1,4-dibromobutene we have how many carbon? 1, 2, 3, 4. 4 carbon are there. In between the second and the third we have double bond. So and also see in the first position, fourth position we had bromine attached. So the name of the compound comes to 1,4-dibromobutene. Why butene? Because see the double bond is between carbon 2 and carbon 3. So it is 1,4-dibromobutene. After that next compound we have is 1-bromo-4 secondary butyl 2-methylbenzene. What is 2-methylbenzene? 2-methylbenzene is toluene attached to it, right? And in that position, first position we have bromine attached to the benzene, and in the fourth position we have secondary butyl. What is secondary butyl? Butyl means how many carbon? 4 carbon are there, and with this 4 carbon in the fourth position we have butyl group attached to it. So in this case what we see that we have a toluene ring, a benzene ring with a methyl, a Br attached over here, and in the fourth position we have this toluene group attached. So okay children, that was about some of nomenclature. We'll discuss more in the next class. Till then children, thank you.